This is examples in music for Module 56. Objective 56.1 says define, identify, label, and calculate retrograde of a pitch segment. Objective 56.2 says identify prime form of a pitch segment. Objective 56.3 says provide proper labels to the following operations to pitch segments. 1. Transpose. 2. Retrograde. 3. Inversion. 4. Retrograde inversion. Let's listen to some of the setting of Little Lamb by Tavener, and then we'll do some analysis. This piece starts out as a serial composition using ordered pitch segments. When the four voices come in, it changes to traditional tonal and functional harmony. That is followed by another section of serial composed music. Here are the opening two measures of this work. We can see that it opens with a series of 5 unique pitches. Some of the notes are immediately repeated, and I'm counting them as one pitch for the analysis. That series of 5 pitches is repeated immediately and exactly in the upper voice, and I've circled them with the same blue box. A different series of 5 pitches appears down here, and I've circled that in the orange box. We'll come back to these first 2 measures later. Following the first 2 measures, we have measures 3 and 4, where one single vocal line introduces this new pattern followed by this new pattern. In the purple box, we have a grouping of 7 different pitches, and in the red box, we have another collection of 7 different pitches. The pitches in the purple box are 7, E, 9, 6, 3, 5, 8. We see them here in integer notation within angled brackets, signifying that these are a segment instead of a pitch class set. The difference being that the order that this appears does matter. It's the exact order that they appear in the piece. The intervals between each set of pitches would be as follows. 7 to E is plus 4, E to 9 is minus 2, 9 to 6 is minus 3, 6 to 3 is minus 3, 3 to 5 is plus 2, and 5 to 8 is plus 3. Again, Objective 56.1 says define, identify, label, and calculate retrograde of a pitch segment. When a pitch segment is in retrograde, the pitches are displayed in reverse order. We can visually see from the notation that the segment in the red box is in reverse order of the segment from the right box. The pitches within the red box are 8, 5, 3, 6, 9, E, 7. This is an exact reverse order of what happened in the previous measure. In red, we start with 8. Over here, we ended with 8. In red, the next was 5, 5, then 3, 3, then 6, 6, then 9, 9, then E, E, then 7, and we started with 7 over here. The intervals between the integers of the red box are 8 to 5 is minus 3, 5 to 3 is minus 2, 3 to 6 is plus 3, 6 to 9 is plus 3, 9 to E is plus 2, and E to 7 is minus 4. In addition to visually seeing that the pitches are in exact reverse order for a retrograde, the intervals of a retrograde segment will also reverse and they'll change direction from what was there before. Over here we have 4, 2, 3, 3, 2, 3. If we read this one backwards, we'll see that we have 4, 2, 3, 3, 2, 3. So the intervals are also in reverse, and the directions will change. We have plus 4, minus 4, minus 2, plus 2, minus 3, plus 3, minus 3, plus 3, plus 2, minus 2, plus 3, minus 3. Again, when the notes of one segment appear in reverse order, that is called the retrograde. Objective 56.2 says identify the prime form of a pitch segment. These are the next two measures of the piece. You'll see that we have the same segment before that we saw in purple. We also have the same segment before that we saw in red. This time there's another vocal line that plays at the same time. If we look at the notes in this light blue box, we have the pitches 7, 3, 5, 8, E, 9, 6. And the pitches inside this brown box are 6, 9, E, 8, 5, 3, 7. 7 pitches in each segment, and as we go deeper into the analysis, we'll see that they're all derived from this purple set. The prime form of a pitch segment means the standard. It's likely the first time when a segment is featured in its full form in a piece of music. You might be thinking that in previous modules, we talked about prime form and that all of them started with the number 0 and could be coupled with an Allen Fort label from the set class table. However, do realize that in previous modules, we were finding the prime form of pitch class sets in set classes. Here, the question is slightly different. We're looking for the prime form of a pitch segment, not a pitch class set. When analyzing pitch class sets, we're talking about the makeup of those notes, and we're not concerned at that time what order they appear in the piece. In this case, when defining the prime form of a pitch segment, we are indeed talking about exactly how the notes appeared in the piece in what order. Therefore, this definition of prime form is different, and once again simply means the standard, the order in which the segment is featured in its first full form of the piece. In measures 1 and 2 of the piece, we notice that we do have a similar segment to what appears in the purple box in measures 3 and 4 and 5 and 6. However, this first segment only involves 5 pitches. The purple segment has 7 pitches, and when analyzing all the other segments, they also have 7 pitches, and they can be related directly to the one in the purple box. So we consider the notes of this segment in purple to be the prime form of the pitch segment. I'll refer to the 5 notes of measure 1 as notes of an intro segment when we analyze that further. Here's another thing to know. If a pitch segment is first introduced as a harmonic chord, you actually need to find the first melodic instance of the segment in order to identify its prime form. In this section of the piece, we see the red box come up again. This is the same content that we saw before, and we identified it as the retrograde of the prime form. Objective 56.3 says, provide proper labels for the following operations to pitch segments. Those are 1. Transposition, 2. Retrograde, 3. Inversion, and 4. Retrograde inversion. We've done transpositions in previous modules. A transposition occurs when we add a constant integer to each pitch in the original prime segment, using Mod 12 arithmetic. The size of the intervals between each pitch of both the prime form segment and the transpose segment will be identical, same direction, same size. In this particular example, I do not have a transpose segment to show you, but you can imagine if we transpose this purple segment by any number, we just add the same number of half steps to each integer, and the intervals would be the same as the intervals as they appear here. We'll come back to these 2 measures in a moment. Let's go back to the first 2 measures of the piece, where we have the 5-note segment, which I called the intro segment. The pitches in this blue box are 7, E, 9, 6, 7. Those notes are repeated immediately and exactly. The intervals between those pitches are +4, -2, -3, and +1. In this orange box, 7, 3, 5, 8, 7. The intervals between those notes are -4, +2, plus 3 minus 1. Here we have two segments that are related by inversion. There are a couple ways of going about to identify this. As we've learned in the past, for an inversion of a pitch segment, the intervals will be the same size, but they will be in opposite directions. So we have 4, 2, 3, 1 over here. We have 4, 2, 3, 1 over here. Here it's plus 4, over here it's minus 4. Minus 2, plus 2. Minus 3, plus 3. Plus 1, minus 1. We can also identify these being related by inversion in the following manner. We can find the inverse of each one of these pitches. The inverse of 7 is 5. The inverse of E is 1. The inverse of 9 is 3. The inverse of 6 is 6. And the inverse of 7 is 5. These two sets are related by direct inversion. We can get to the integers of the orange segment if we transpose the integers of the inversion segment. We transpose this by 2, we get 7, 3, 5, 8, 7, proving our inversion relationship of these two pitch segments. Let's go back to these two measures and look at the light blue segment. Looking at the intervals in comparison to the prime form, we have the same numbers, 4, 2, 3, 3, 2, 3. But the directions are reversed, minus 4, plus 2, plus 3, plus 3, minus 2, minus 3. Therefore, this blue segment is in inversion of the prime form. Finally, if we look closely at the notes of the brown box, we'll see that they are in reverse order of this inversion. This goes 7, 3, 5, 8, E, 9, 6. And if we read this one backwards, 7, 3, 5, 8, E, 9, 6. From left to right, they are in reverse order of this inversion. This is called the retrograde inversion of the prime form. To obtain a retrograde inversion, you go to the inversion first and then reverse the order, as is done here. So in these two measures, we have 4 different forms of the same segment. We have the prime form, the inversion, we have the retrograde, and the retrograde inversion. Notice again, for the retrograde inversion, the interval numbers are the same as the inversion segment in reverse, as well as the plus or minuses have changed. Here are the opening 6 measures of the piece. We have an intro segment, then a repeated intro segment played at the same time within an inversion of the intro segment. Then, in one single voice, we're given the prime form of the main pitch segment of the piece. Immediately afterward, that pitch segment is performed in retrograde. Then we have the prime form offset with an inversion of the prime form. Then a retrograde of the prime form offset with a retrograde inversion of the prime form.